Okay guys, so today to start our new unit, we're actually going to review something that we did from the first semester. So if you guys remember, one of the very first things we learned in this class was how to find the exact value of certain trig functions. So we did regular exact values and we also did inverse values. So we're going to just refresh how to do both of those. So the very first example we have here is finding the sine of 30 degrees. So if you remember what we needed to do in order to figure this out, that's the ratio of the opposite over hypotenuse of a 30-degree angle. So what we did was we drew a 30-degree angle and we made that into a triangle with the x-axis, always with the x-axis. And then because that's a 30, 60, 90 triangle, we know it follows that same ratio of x times the square root of 3, and 2x. So once I have my triangle filled in order to find my exact value, all I have to do is fill in my opposite over hypotenuse of 30 degrees. My opposite is 1, my hypotenuse is 2. So the sine of 30 degrees is 1/2. Now we also did these with radians. Now with radians, we worked it out the same way. We just had to remember where those radians were in order to draw them. So if you remember, all the way around the circle is 2 pi. And then halfway around is 1 pi. Which means if we had a common denominator, that would be 4 pi over 4. So if that's 4 pi over 4, halfway between those would be 2 pi over 4, which means 3 pi over 4 we know is going to fall in that third quadrant. Now the other thing we know is that every radian value has a corresponding degree value. So a pi over 4 radian is the same thing as 45 degrees. Then we also learned that pi over 3 was 60 degrees, and pi over 6 was 30 degrees. So to fill in that reference angle here, we know this reference angle, because it's pi over 4, that reference angle is 45 degrees, which means I can fill in with those ratios a 1, 1, and the square root of 2, but because I'm in the second quadrant now, I have to remember that 1 on the bottom is negative. So now to find my tangent ratio, that's opposite over adjacent, which is 1 over negative 1. And then the other kind of question that we saw was something like this next one, where I'm trying to find the cosine of pi. So if I try and draw pi, the angle pi is actually this line over here. That's my pi radians. I can't draw a triangle when it's on the line. So in order to find that one, there's a couple different ways I could figure it out. One of them, we had that little chart. The OIO, IOU, oh I don't owe you. And if you remember, that chart went sine, cosine, tangent, and then it started at 0, and then it went to 270, or 3 pi over 2. We know that 180 degrees is the same thing as pi, which means that the cosine of pi is negative 1. The other way we looked at this, we talked about how the x-coordinate was always our cosine, and the y-coordinate is always our sine. So if that's a point on the unit circle, that point, those coordinates are negative 1, 0. And my x-coordinate is my cosine, which is negative 1. It's a little bit of a faster way of doing it, if you can remember what's x and what's y. And the last thing we did was, a couple weeks after that, we talked about inverse values. So inverse values are basically going in the opposite order. So instead of giving the angle and trying to find the ratio, it gives us the ratio and we need to find the angle. And there were two types of these. We found principal inverse values, and we found our general solutions under a certain restriction. So what we're going to do first is we're going to find the principal value. Remember, the principal value is kind of the first one, the one the calculator gave you. So for cosine, if I'm trying to find the cosine inverse of a positive ratio, all the positive ones, the principal value is always in the first quadrant. So I draw that triangle in my first quadrant. Cosine's ratio of adjacent over hypotenuse. So my adjacent side here is the square root of 3, and my hypotenuse is 2. Well, then if I do the Pythagorean theorem, my missing side is 1, which means that reference angle there has to be 30 degrees. So the principal inverse value there is 30 degrees, or if I want to do it in radians, that's the same thing as pi over 6. Now the other thing we had to look at was a general solution. So my general solution was when I looked at this basically everywhere it could possibly be true. And in order to do that, I had to find a second quadrant. So in this case, I'm looking for where cosine is positive. I know cosine is positive where they all are, and cosine is also positive in the fourth quadrant. So what that means is I actually need to find that same triangle in the fourth quadrant. I still have an adjacent of square root of 3 and a hypotenuse of 2 and a missing side of 1 with Pythagorean theorem, which means that angle down there has the same reference angle. But I don't want the reference angle, I want the whole angle. So if it's 2 pi all the way around, and that reference is pi over 6, then that angle is 11 pi over 6. So if this question were to ask for all of the solutions between 0 and 2 pi, my two answers would be pi over 6 and 11 pi over 6. Or if I wanted to write the general solution, remember I would take both of those values and I would write plus 2 pi n, because I can add any multiple of 2 pi and still get that answer. Alright, so let's look at one more inverse value. So if I have this inverse value, I want to find tangent inverse of negative 1 over root 3. And I'm going to start with the principal value. So the principal value when tangent is negative is in the fourth quadrant. I've got an opposite of 1 and adjacent of root 3, which means my hypotenuse is 2 with the Pythagorean theorem. So that means this reference angle there, if I'm doing this in radians, let's do it in radians, has to be pi over 6. But remember, I don't want that reference angle, I want that full angle. Now the principal value here would technically be the easiest way to find it, which is a negative pi over 6. That would be my principal value. But let's look at what it's asking for. It wants all of my answers between 0 and 2 pi. So between 0 and 2 pi, that has to be a positive number. So instead of using negative pi over 6, I'm going to use the positive version, which is 2 pi minus pi over 6, which is 11 pi over 6. Then I also need to find the other place where tangent is positive. Tangent is also positive in the second quadrant. Same reference angle, which means that full angle there is pi minus pi over 6, which is going to be 5 pi over 6. So those are the two places between 0 and 2 pi. And that principal value, if I needed to find that instead, that principal value would have been a negative pi over 6. Now remember, negative pi over 6 and 11 pi over 6, they're the same angle, just written in a different way.